happens every day. A motor vehicle catches fire on a busy highway, city street, or crowded parking lot. It starts small, but within minutes the vehicle is fully engulfed in flames. Toxic smoke pours from the vehicle, endangering passers-by. Radiant heat threatens nearby vehicles and buildings. Fumes in the gas tank are ready to explode. Many firefighters unwisely think vehicle fires are harmless, commonplace. But every year, firefighters are seriously injured or killed while fighting vehicle fires because of carelessness and lack of proper protective equipment. According to the National Fire Protection Association, 1 in 6 of all reported fires involves a motor vehicle. Vehicle fires are caused by a variety of factors, including collisions, poor maintenance, defective components, carelessness with smoking materials, and arson. To ensure your safety, you must control a number of deadly hazards, use proper protective equipment, and understand the specialized extinguishment techniques that will keep you alive while fighting vehicle fires. In this program, we will demonstrate the importance of donning protective equipment, how to prepare a pre-incident plan, how to respond to and secure the fire scene, how to size up the incident, how to extinguish vehicle fires, and overhaul. Protective equipment is important to keep firefighters safe from potentially deadly hazards while fighting a vehicle fire. Burning rubber, plastics, and upholstery give off toxic smoke. Engine hoses can burst, spraying burning fuel or boiling liquids. Batteries can explode and spray acid. Many gas-filled pressurized and hydraulic components can explode or fail, including bumpers, shock absorbers, pneumatic cylinders on hatchbacks, airbags, and even drive lines. Vehicles may be carrying highly toxic materials, such as chemicals used in clandestine drug labs. To protect themselves from these hazards, firefighters must be fully protected before approaching the scene. Proper equipment includes fire protective boots, bunker pants, and turnout coat. Collars should be turned up, a helmet with the face shield down, and firefighting gloves. There is no such thing as a routine vehicle fire. Firefighters must avoid the attitude of contempt for the commonplace, because a seemingly routine vehicle fire could become a serious threat in seconds. A pre-incident plan should be in place with standard operating procedures for vehicle fires. The pre-incident plan should have detailed road maps, including the location of freeway on and off ramps, and median strip crossover locations. Potential problem areas should also be noted, such as road construction, structures adjacent to roadways, such as tank farms and factories, and highly populated areas, such as housing subdivisions and schools. The pre-incident plan should note structures that can hamper response if they are threatened by vehicle fires, such as tunnels or underpasses, high-rise or underground parking garages, and crowded parking lots. Firefighters must know the location of hydrants and other water supplies, including water supplies in restricted areas, such as on freeways. Other important information is the location and availability of specialized agencies and equipment, such as hazardous materials teams, tankers for water supply, diking supplies for fuel and hazardous material spills, and tow trucks. Up-to-date copies of the pre-incident plan should be carried on each apparatus, and crews must be alerted to unusual conditions, such as construction projects that may alter plans during an emergency. Responding to and securing the fire scene includes accessing the incident, spotting the apparatus, and traffic control. Accessing the incident is often hampered by a number of factors. If the fire scene is on a freeway, it may be difficult to reach because of median strip barriers and the distance between on and off ramps. Congestion near the incident may also hinder firefighters' ability to respond quickly. Often there is a delay in reporting incidents on freeways because of the lack of telephones in such areas. Because of this delay, vehicles are more likely to be fully involved by the time you arrive at the fire scene. Also, people reporting vehicle fires often have difficulty describing the exact location of the incident. If the exact location of an incident is not known, it may be necessary for units from 2 stations to respond. For example, on an east-west road, 2 units would approach each other, 1 unit going east and the other unit going west, until the fire is located. Properly spotting the apparatus is an important safety consideration. If you need to move the apparatus off the pavement, check the terrain of the ground where it will be spotted. Be sure that soft ground or steep slopes will not hinder your ability to safely spot the apparatus and leave the scene after the incident. If possible, spot the apparatus uphill, upwind, and at least 75 feet from the burning vehicle to help protect firefighters and the apparatus from smoke, fire, radiant heat, and explosions. Positioning the apparatus at an angle across traffic lanes nearest to the incident can provide firefighters protection from moving vehicles. Some areas will not allow apparatus to be spotted close to the fire scene. One example of such an area is an underground parking garage. Low clearance or narrow lanes will require the apparatus to be spotted outside the structure. In this situation, spot the apparatus as close as possible to the incident. Hoses can then be stretched and equipment carried to the fire scene. To ensure scene safety, traffic control measures will be required. When responding to an incident, confirm that law enforcement personnel are en route or at the scene to coordinate these functions. If law enforcement personnel are not already on scene when the apparatus arrives, the incident commander should assign a firefighter to coordinate traffic control until law enforcement personnel arrive. The type of roadway and the location of the burning vehicle will determine how traffic should be controlled. A detour should be established on roadways that have good access to alternate routes to keep traffic away from the incident. On freeways, or where detours are not possible, create a buffer zone between the fire scene and passing motorists to protect firefighters. If the vehicle is off the roadway, at least one adjacent lane should be closed. If the vehicle is blocking a lane, close that lane plus an adjacent lane or lanes to act as a buffer zone. If hazards do not allow motorists to pass the incident safely, close the entire roadway until the hazards have been controlled. To warn motorists of the incident, traffic cones or flares should be placed in a pattern that will create a safe area around the fire scene. Flares should be used at night or when visibility is poor. If flares are used, keep them out of the path of leaking fuel or combustible materials. Be aware that well-meaning citizens or law enforcement personnel may place flares in a dangerous area, such as in the path of fuel spills. Space traffic cones or flares between 10 and 35 feet apart, depending on the number you have available to use. A very general rule of thumb can be used to determine the total length of the traffic control pattern. To determine the length, multiply the speed limit by 10 and add the length of the work area. For example, on a 35-mile-per-hour road, multiply 35 by 10 for a total of 350. If the work area is 100 feet, add 100 for a total of 450. Terminate the pattern approximately 50 feet past the work area. The total pattern length should be 500 feet from start to finish. Consider hazards that may prevent motorists from seeing the incident in time to stop safely. Curves or hills may keep motorists from reacting quickly. Smoke, fog, or darkness may obscure drivers' vision. Material on the roadway, such as water or leaves, may increase stopping distances. Be sure floodlights or headlights on the apparatus do not blind motorists. If the area is controlled by traffic signals, make sure any traffic light control devices mounted on the apparatus are turned off to allow signals to operate normally. Regardless of traffic control procedures, curious motorists may endanger firefighters by not watching where they are going. At all times, be cautious and be alert for traffic hazards. Performing size-up tasks simultaneously allows firefighters to begin extinguishing the fire more quickly. Upon arrival at the fire scene, the incident commander should assign tasks to firefighters, working individually or as a team. Size-up includes approaching the vehicle, search and rescue, protecting exposures, and identifying flammable and toxic materials contained in the vehicle. The first step is approaching the vehicle. If power lines are down, do not approach the vehicle or begin extinguishment until power is disconnected by the power company. Approach from the sides of the vehicle because of the risk of explosion from the fuel tank or engine components. To stop the flow of fuel, turn off the engine and remove the keys if the passenger compartment is accessible. Stay clear of the fuel tank filler cap. As heat increases pressure in the fuel tank, the cap can be blown from the filler neck, spraying fuel. If possible, and if time allows, stabilize the vehicle with wheel chocks or cribbing to prevent its movement during rescue and extinguishment operations. Many larger vehicles, such as straight trucks and tractor-trailer rigs, are equipped with compressed airbags to help cushion the suspension. During a fire, these airbags can burst, allowing the vehicle to drop as much as 8 inches. For this reason, firefighters should never place their hands in the area above the tires when directing hose streams. Next, begin search and rescue operations for victims. Always have at least 1.5 inch hose line charged and ready at all times when performing operations near a burning vehicle to provide protection for firefighters and victims. Hose line should be capable of delivering at least 100 gallons per minute. If victims are in the vehicle and do not require disentanglement, remove them immediately and perform emergency care procedures. If victims are trapped in the vehicle and cannot be removed immediately, protect them with hose streams using wide pattern fog nozzles. If trapped victims are threatened by smoke, place an SCBA mask on their face to provide respiratory protection while operations to free them are underway. Because of the flammability of pure oxygen, never give victims oxygen until they are removed from the fire scene. Opening windows or doors, combined with fog streams, will help ventilate the passenger compartment. If doors are locked, break a window by striking it in a lower corner with an axe tip. If possible, break a window away from the victims to prevent injury from flying glass. A spring-loaded automatic center punch is another effective tool for breaking glass. Power rescue tools, such as a hydraulic spreader, may be used to open jammed doors. Since victims in the vehicle may be obscured by smoke, ask the driver, passengers, or witnesses outside the vehicle if additional victims are still in the vehicle. If you cannot confirm that the vehicle is clear, initiate a search by reaching into the vehicle and feeling for victims. A rescuer on each side of the vehicle will speed the search. Search all areas of the passenger compartment. Small children may be on the floor. If heavy fire involvement prevents such a search, apply a fire stream to the passenger compartment. If a victim is secured by a seat belt, it may be faster and easier to cut the belt rather than release the latch. If a collision has occurred, search the surrounding area for victims. Search a minimum of a 100-foot radius around the vehicles, including the area underneath the vehicles. Notify the incident commander that the vehicle and surrounding area are clear after the search has been completed and all victims have been removed. Protecting exposures will keep the fire from spreading to surrounding areas and limit damage. Survey the area around the vehicle to determine what may be threatened by the fire. Other vehicles within 75 feet of the burning vehicle should be moved or protected with hose streams using a fog nozzle. Nearby structures should also be protected with hose streams and evacuated if necessary. Vegetation in the vicinity of the fire should be soaked to prevent its involvement. Identifying flammable and toxic materials will allow firefighters to determine the best extinguishing methods and the threat to the surrounding area. To identify hazards, visually inspect the vehicle. If possible, question the driver about what hazards are present, such as gasoline cans, flammable materials, firearms, ammunition, or hazardous materials. Ask the driver how much fuel is in the tank. Fuel tanks that are nearly empty contain more vapor and are more of an explosion risk than full tanks. If portable fuel containers are carried in the vehicle, cool them with water to help prevent ignition until they can safely be removed. Some commercial vehicles are powered by or carry compressed or liquefied fuels such as natural gas and propane. Propane is sometimes referred to as LP gas or liquefied petroleum gas. In automobiles, the large gas cylinder is usually located in the trunk. In light trucks and vans, it may be suspended under the chassis. Vehicles powered by natural gas or propane often display a sticker or placard indicating this fact. Propane can also be found in recreational vehicles, where it is used for cooking, heating, and refrigeration. On some small travel trailers, the propane tank is typically found mounted on the tongue. On larger trailers and recreational vehicles, the tank may be located behind an unlocked access door. Fuels in pressurized tanks carry the risk of causing a BLEVE when exposed to heat. BLEVE stands for boiling, liquid, expanding, vapor, explosion. A BLEVE occurs when heat causes pressure inside the tank to exceed the tank's ability to contain it. A BLEVE sprays fuel and can propel pieces of the metal fuel tank with great force for a considerable distance. Therefore, a BLEVE is extremely dangerous for both firefighters and bystanders. While most pressurized fuel tanks are equipped with a relief valve to prevent an explosion, the possibility of a BLEVE cannot be ruled out. Even if the relief valve functions, fuel will be sprayed from the tank and may ignite. Cooling fuel tanks with water will lessen the risk of explosion or fuel release. This is effective for both pressurized fuel tanks, such as propane, and non-pressurized fuel tanks, such as gasoline and diesel. If fuel is leaking, cover the leak with foam to prevent ignition. If foam is not available, cover the fuel with absorbent materials or dirt. Dikes can be used to contain fuel and keep it away from ignition sources, such as flame and electricity. Ruptured fuel tanks can be plugged with a sealing compound. Ruptured fuel lines can be crimped shut with pliers or raised to stop the flow of fuel. Waterways, such as streams and drainage ditches, and nearby storm drains should be protected from fuel and other toxic materials by diking or covering fuel with dirt. Trucks, vans, and other commercial vehicles are more likely to be carrying flammable and hazardous materials. The driver may be incapacitated or unaware of the types of cargo contained in the vehicle.
What's in the truck?
If you can safely get to it, Inspect the cargo manifest, which will usually be located in the cab or carried by the driver. The exterior of the vehicle may display Department of Transportation placards indicating hazardous or flammable cargo. If the company name can be seen on the outside of the vehicle or is on papers in the passenger compartment, attempt to contact the company to determine what kind of cargo is carried in the vehicle. Vehicle license numbers can also be used to determine the vehicle owner, with the assistance of law enforcement personnel. If the cargo cannot be positively identified, begin the attack from a distance to protect personnel because the cargo may react with the extinguishing agent. Approach the vehicle with extreme caution using a fog stream. Depending on the nature of the cargo, it may be necessary to contact hazardous materials experts for advice. Next, extinguish the fire. Extinguishment includes accessing the seat of the fire and applying the extinguishing agent. First, access the seat of the fire. The area of heaviest smoke and flame will usually indicate the seat of the fire. Fire may be located in the engine compartment, the passenger compartment, or other areas. Many vehicle fires begin in the engine compartment because it contains numerous flammable components such as fuel, hoses, and wiring, and is the area of greatest heat. Engine compartment fires are commonly caused by faulty or worn components. Heat may cause shock-absorbing bumpers to propel forward several inches, injuring firefighters. For this reason, cool bumpers with water before performing any operations in front of the vehicle. For safety, cool an engine fire before the hood is opened by applying water through the radiator or from under the engine compartment. A dry chemical extinguishing agent applied in combination with water can help extinguish the fire. Accessing the engine compartment is often difficult because the hood release cable can melt in the early stages of the fire. If the hood release cable is inoperable, the hood latch can be freed using a pry bar or hydraulic tool. Use caution when opening the hood if the engine compartment is producing a lot of heat or smoke, because the inrush of air can cause the fire to quickly intensify. Heat can also cause the failure of springs that hold some hoods open. Support these hoods with a pry bar or other tool. The passenger compartment is another common area for vehicle fires. One cause of fire in the passenger compartment is an electrical short circuit. Smoke coming from the dash alone usually indicates an electrical fire. Passenger carelessness with smoking materials is another common cause of fire in the passenger compartment. Smoking materials can ignite upholstery, carpeting, or flammable materials in the car, such as papers or trash. Other areas where the seat of the fire may be located include tires, brakes, and cargo areas. If fire is in the trunk and the key is not available, remove the lock by placing the tip of a halogen or other tool on it and striking it with an axe. In some cases, a vehicle is totally involved in fire before firefighters arrive at the scene. In this situation, apply water from a safe distance to reduce the fire and then carefully approach the vehicle to completely extinguish the fire. After accessing the seat of the fire, apply the extinguishing agent. The proper extinguishing agent is determined by the types of materials that are burning. Burning materials in vehicles may be Class A, Class B, Class C, or Class D. Class A fires involve ordinary combustibles, such as cloth, plastic, and rubber. Class A fires are extinguished with water. Apparatus tank water is commonly used to attack vehicle fires. In most cases, one engine will carry enough water for extinguishment. If more water is required, request additional units or connect to the nearest hydrant. For fires in the engine compartment, Apply water immediately after the hood is opened, moving the nozzle in a circular manner. Most engine fires can be quickly extinguished using this method. After fire in the engine compartment has been extinguished, carefully disconnect or cut the battery cables, ground side first, to prevent arcing and reignition of the fire caused by an electrical spark or short circuit. For Class A fires in the passenger compartment, aim a fog nozzle toward the roof to spread the water and knock down the fire. Then extinguish any hot spots by applying water directly onto them. Class B fires involve flammable liquids, such as gasoline and diesel fuel. Class B fires should be extinguished using foam. Aqueous film-forming foam, known as AFFF, is particularly effective in extinguishing gasoline and diesel fuel fires. To extinguish a Class B fire, apply a foam blanket to smother vapors. Never apply water to a Class B fire because water will only spread the fire. Small Class B fires may be attacked using a portable fire extinguisher rated for such use. Class C fires involve electrical equipment, such as batteries, wiring, and electrical components. Class C fires are commonly knocked down using a portable extinguisher containing carbon dioxide or halon. The presence of smoke or sparks with minimal flame usually indicates an electrical fire. Electrical fires may be located in the engine compartment or in the passenger compartment, usually in the dash. Aim the extinguisher at the seat of the fire and sweep the area. Disconnecting the battery cables will eliminate the source of electricity. If required, open the dash with a pry bar or other tool to expose burning wires. Electrical fires may ignite Class A materials, which can be extinguished with water. Class D fires involve combustible metals, such as magnesium. Pre-1971 Volkswagens contained magnesium engine components. Some motorcycles also have magnesium engine components. While extinguishing powders, such as Metalex, are commonly used to attack combustible metal fires, they are not effective on vehicle fires because the shape and position of the metal components does not allow the powder to completely cover the burning material, as required for extinguishment. Burning magnesium is easy to identify because when hit with water, it will react violently, sending pieces of burning debris in all directions. While water will not extinguish a magnesium fire, it should be applied to help extinguish non-magnesium materials or keep them from igniting. Firefighters should retreat to a safe distance, at least 25 feet away, and apply large amounts of water. Because of the high water requirements in fighting a magnesium fire, water may need to be supplied from a hydrant, or additional units should respond. Continue to apply water until the magnesium burns itself out. No other extinguishing agent should be applied to burning magnesium because of the potential for a more violent reaction and the formation of toxic gases. After the fire has been extinguished, begin overhaul operations. Overhaul is required to keep smoldering or hidden fires from reigniting the vehicle. Overhaul should be done in the engine compartment and the passenger compartment if the fire entered those areas. To overhaul the engine compartment, check for and extinguish spot fires that may have reignited after initial extinguishment, including areas underneath and around the vehicle. Check for fuel leaks and plug any that are found with tape or putty. Cover small amounts of fuel on the ground with dirt or foam. Dike the area on the ground around the engine compartment if necessary. Check to be sure the battery is disconnected. Remove the air filter. Because air filters are made of paper and are contained in an enclosed space, they may smolder for a long time and not be noticed. To overhaul the passenger compartment, Remove any loose combustible material, such as items carried in the vehicle. If seats were involved, they should be thoroughly wet down. Open the dash area and extinguish any fire that is found. Open the trunk, remove combustibles, and wet down the area. Check to see if tires are smoldering. If they are, extinguish them with water. After overhaul operations are complete, contact other personnel that may be required to respond, such as fire investigators. When it is safe to do so, indicate to law enforcement personnel that they may begin to restore normal traffic flow. Every year, firefighters are seriously injured or killed while fighting vehicle fires because they were careless or didn't wear proper protective equipment. The risks of a levee, exploding batteries, toxic smoke, spraying fuel, and other hazards require all firefighters to wear full protective clothing and SCBA. They are your only protection against the dangers you may encounter. A vehicle fire pre-incident plan must be worked out in advance. Standard operating procedures should be established to aid in exposure protection, working in tight spaces, and alternate methods of extinguishment. Secure the scene on the roadway to protect your crew from being struck by passing motorists and to protect motorists from fire hazards. Size up the scene carefully to identify hazards and determine the most effective method of extinguishment. Extinguish the fire with the proper agents for the types of materials that are burning. And take steps to completely overhaul the fire scene before leaving the area. Every vehicle fire has the potential to become a hazmat situation. Never underestimate the dangers that may be present. Using safe and effective techniques will keep you alive while fighting vehicle fires.